It's important to emphasize that these nodes are not perfect. 3D vision, its effectiveness and comfort is different for individuals, and there is no one-size-fits-all. On top of that, the quality of the input video can impact the quality of the output. You will need to experiment with the settings for what is right for you and your viewers. Welcome to the 3D Video Effects Pack. First up on the list are two helper nodes that, whilst aren't 3D related, they can help with the final production of a video. So, what is the ease in and ease out node? This node simply takes the start of the video or batch images and starts them off at a reduced speed, slowly ramping up to normal speed. The same applies to easing out. It takes the video and slightly slows it down at the end. You can see this in the video on the screen where the man slows down before reversing backward. Even the reversing is smoothed back in again. The node is configurable to set the number of frames to speed up or slow down, plus also allows you to just ease in just the start, ease out the end, or do both ends. It is extremely useful to remove the abrupt start-stop of a video or smooth the harsh ping-pong effect that the VHS combine node gives you. Next, we have the bullet time node, which causes a slowdown in the middle of the video using time dilation. You decide where the slowdown starts and ends. The ramp frame settings is the number of frames that are used to slow down before the middle or speed up after the middle. This value must not be larger than the difference between the slow start frame and slow end frame numbers doubled. For example, if you slow start at frame 100 and slow end at frame 120, the maximum ramped frames you should enter is 9. If you have difficulty knowing the frame numbers, you can use the image batch number overlay node, which will put the frame number over each frame. Now we get to the first of the 3D effects. The 3D pop node gives a 3D type of effect, using bars at the top and bottom to give the illusion of 3D, which some would call 2.5D. The bars use depth maps to determine what is close to the screen, which help it understand what to pop out. The preset setting selects a tuned stability profile for the pop 3D effect. Face Safe is designed to protect faces and fine detail, while stronger presets increase depth separation and visual impact. Strength controls the overall intensity of the 3D pop. Lower values produce a flatter, more subtle effect, while higher values increase the sense of depth but can exaggerate edges if pushed too far. Depth cutoff anchors the foreground. When disabled, all depth values are used normally. When increased, nearer areas such as faces are stabilized and prevented from being pulled inward, improving portrait and close-up results. Bars mode controls how the top and bottom bars behave. Overlay mode keeps the bars permanently visible and allows near objects to appear inside them at all times. Breakout mode only shows bars when near depth reaches them, creating a dynamic window violation effect. Breakout cutoff sets the depth threshold required for objects to break into the bars. Lower values allow more areas to break out, while higher values restrict breakout to only the closest parts of the image. Halo Fix reduces bright or dark outlines along breakout edges. Increasing this value cleans up hair, shoulders, and other fine details near the bar edges. Bar Smooth enables temporal smoothing for video batches. When enabled, bars fade in and out smoothly over time instead of snapping on and off between frames. Bar Smooth Look Ahead defines how many future frames are checked to anticipate breakout. Larger values cause bars to appear earlier before an object reaches them. Bar Smooth Fade controls how long bars remain visible after breakout ends, allowing them to fade away smoothly. Separate bars allows the top and bottom bars to be controlled independently. This is useful because hair and ceilings behave differently from feet and ground surfaces. Top bar off disables the top bar completely, preventing both the black bar and any top breakout. Top breakout cutoff sets the depth threshold used only for the top bar when bars are separated. Top Halo Fix controls edge cleanup specifically for the top bar. Top Auto Cancel prevents tiny or accidental breakouts, such as a few strands of hair, from triggering the top bar. It checks a small strip at the bar edge and cancels the bar if there's not enough near-depth coverage. Bottom bar off disables the bottom bar completely. Bottom breakout cutoff sets the depth threshold used only for the bottom bar. Bottom Halo Fix controls edge cleanup for the bottom bar. Bottom Auto Cancel prevents unwanted black gaps on ground surfaces. If the bottom of the image is mostly near depth, the bottom bar is automatically canceled for that frame. It is advisable to keep this toggled to true, as most issues with this technology occurs at the ground. The Pulfrich effect is a motion-based 3D illusion where depth is created by showing one eye, a slightly delayed version of the same image. When there is sideways motion in the scene, this small timing difference causes the brain to perceive depth even though no depth map or spatial stereo camera is used. This node takes a sequence of images and converts each frame into a side-by-side Pulfrich 3D image, suitable for YouTube and other stereo video players. The delay frame setting controls the strength of the Pulfrich effect by defining how many frames one eye is delayed relative to the other. A value of 1 frame is ideal for 60 frame per second video, producing strong depth while remaining comfortable. Larger values increase depth but can quickly cause discomfort, especially at 30 frames per second. The pad mode setting controls how the node behaves at the start of the sequence, when there are not yet enough earlier frames to apply the delay. Hold first repeats the first frame, loop wraps around from the end of the sequence, and mirror reflects frames near the beginning to avoid a looping appearance. The fade-in frame setting softens the start of the effect by gradually introducing the delayed image over several frames, preventing a sudden or jarring depth jump at the beginning of the clip. The delayed eye side setting chooses which eye receives the delayed image. The default is the right eye, which matches most classic Pulfrich demonstrations, and changing this reverses the perceived depth direction. The swap eye setting swaps the left and right halves of the final side-by-side image. This is useful if the depth appears inverted on certain displays or players. The dim delayed eye setting optionally darkens the delayed eye image. This mimics the traditional Pulfrich sunglasses effect and can slightly strengthen the illusion, but it is not required and should be left at 0 if the viewer is already wearing dark glasses. If you want text on the screen, use the Text Overlay Timeline node, where you type one line of text per overlay. Each line starts with a frame range written as start-end, for example, 0-250. After that, you add a vertical bar, then the text position, such as center, top_center, or bottom_right. You can also use an exact position by writing x equals number and y equals number. After another vertical bar, you type the text you want to appear. Anything after the final bar is drawn exactly as written. The 3D Anaglyph node takes a left image and a right image that already contains stereo parallax and converts them into a single Anaglyph 3D image for viewing with colored glasses. The left and right images should come from a stereo or SBS camera node and must not be identical, otherwise no 3D depth will be visible. The Anaglyph type setting controls how the stereo views are encoded into color channels. Red and cyan is the standard format and works with most glasses. Red and green is an alternative format for specific displays or glasses. Amber and blue is included for compatibility with older or specialty Anaglyph glasses. The depth strength setting applies a small horizontal pixel shift to both images before encoding. Increasing this value increases the perceived depth, while decreasing it reduces depth. This control is intended only for fine-tuning and comfort adjustment, not for creating stereo from flat images. The channel balance setting adjusts how strongly the non-dominant color channels contribute to the final image. Lower values reduce color ghosting and eye strain at the cost of color saturation, while higher values preserve more color but may increase ghosting. The output is a single image at the same resolution as the inputs, encoded as an Anaglyph image that can be viewed in any standard image or video player using the appropriate glasses. The SBS camera node creates rectified side-by-side stereoscopic images, meaning a flat left eye and right eye pair placed next to each other horizontally, like a traditional SBS 3D image. It does not use fisheye or dome projection, and it is designed to be comfortable to view and suitable for further processing on VR headsets. The latent input is the diffusion latent that will be shifted for stereo consistency, and the image input is the matching decoded RGB image, which is used to calculate depth and to generate the visible left and right images. The IPD setting controls the simulated eye separation, where larger values increase the stereo effect and smaller values make it subtler. Depth strength scales how strongly depth differences affect stereo separation overall. Max disparity sets a hard limit on how far pixels are allowed to shift horizontally, which is important for avoiding eye strain. Foreground boost increases stereo separation for objects closer than the focus plane, while background boost increases separation for objects farther away, allowing you to emphasize pop-out or background depth independently. The stereo preset dropdown lets you quickly switch between predefined looks such as cinematic, strong pop, portrait, or VR 180 preparation. When the preset is set to default, all slider values are used exactly as you set them. When any other preset is selected, the preset internally overrides the values and the sliders are ignored. Median focus automatically places the focus at the median depth of the image, which is usually the most stable option. Manual focus lets you explicitly choose a focus depth between 0 and 1, where lower values bring the focus closer to the viewer and higher values push it deeper into the scene. The manual focus value is only used when focus mode is set to manual. Use internal depth enables automatic depth estimation from the image using MyDes when available, with a luminance fallback if not. Invert internal depth flips that internally generated depth in case near and far are interpreted backwards. An optional external depth image can be provided instead, and invert external depth flips that depth map so it matches the node's convention of near being 1 and far being 0. The node outputs left and right latents, left and right full resolution images, a depth preview showing the depth actually used, a combined side-by-side image with left and right concatenated horizontally, and a text debug string. When the preset is default, the text debug output contains the full set of numeric values used. When any preset is selected, the text debug output is simply the preset name. Skybox VR needs _full_SBS somewhere in the file name for it to automatically understand the format of the video. All the example videos and images are available in the workflow folder. This also includes all the workflows seen in this video. Thank you for taking time to watch the tutorial. I'm not precious about views or subs, but if you want to, please hit the thumbs up.